Hi, everyone. Today we're going to go over absolute value. We're also going to talk about polynomial functions. But let's start with absolute value. So for absolute value, we need to know a few things about the equations for absolute value and the inequalities for absolute value. We also need to know about what absolute value means. So absolute value has to do with the distance from zero, or the absolute distance from a point. So if we're talking about the distance from -5 to 0, that distance would be 5. Its absolute value is 5. That's kind of an overview of what absolute value is. But let's take a look at the PowerPoints for the SAT. So we're going to see equations with absolute value written something like this: -5. Absolute value of -5 is 5. Absolute value of 5 is 5. If x is 5, then x can either be 5 or -5. But if we write something like absolute value of 5 is x, then x can only be 5. This gets a little bit tricky when we're talking about x's in the absolute values. But for now, just know that the number, if it's a negative inside the absolute value, it's a positive. And if it's a positive, it's still a positive. When we solve an equation with absolute value, we can have two answers because of this. So we get either a positive value or a negative value. That's all this slide says here. It says if absolute value of A is B, then A could be B or it could be -B. Here's a numbers example. So whenever we solve absolute value, the first and most important thing that we should do is we should move the constants to the other side. So we're going to -3 on both sides. Now we have absolute value x minus 4 equals 7. Now we're going to use that same rule where absolute value of A equals B. And actually, I should technically write or. And the absolute value of A is -B. So if we follow that rule for this one, we get x minus 4 equals 7, just like a normal problem, or x minus 4 equals -7. And now we just solve these algebraically. And we get x is 11. And for this one, we would get x is -3. So we have two answers for this absolute value. And that's always going to be the case when we have absolute value equals something. Okay, moving forward, let's take a look at the next question here. So those are going to be our answers. And you always have to be careful to look at what it says as far as what the question is asking us to find. So is it asking us to find those two answers, or is it asking us to find something else? So if we go back up here, it says, what's the product of the solution set? So our solution was -7, or excuse me, our solution was, when we solve this, we got 11 and -3. And so when we multiply those together, we get -33. We can also write absolute value as an inequality. You might be thinking, oh, well, it's kind of the same rule as we do for equals. And it kind of is the same rule. But when we have a less than inequality, when x is less than a value, we write it as a between statement. So we put x in the middle, drop the inequality sign, and we make this a is just whatever number that is that goes on the right side, and then the negative value of that number goes on the left side. If the absolute value of x is greater than a, something happens that's a little bit different. It's not a between statement anymore. Now, if it's greater than a, what happens is we write two separate or statements. So if it's greater than a, for one of them, we drop the inequality sign and just write x is greater than a. But for the second one, we write or, We write x, switch the inequality sign, and switch the sign on the constant. So again, it might be a little tough to picture with the letters only. So let's look at a question with numbers. So it says, what integer values of x satisfies the equation? So integer values, those are just our counting numbers, 1, 2, 3, 4, 5, etc. So this is a less than inequality. So for this less than inequality, if we go back up to our rule for the less thans, that means that we write a between statement. So if we go down here, this is a between statement. So let's write this as a between statement. So without the absolute value. So we're going to write 3x minus 2 is less than 3. That's our first part, dropping the absolute value. And then we just write that as -3 on the left. And all the arrows should be pointing the same way, and they should be pointing to the negative value. Now, when we solve this, we're going to solve it like balancing it and think of it as there's 3 sides to the equation. So we're going to plus 2 on all 3 sides. This is -1 is less than 3x is less than 5. Divide by 3 on all 3 sides. We get -1/3 is less than 3 over 3, which is just x. And that's 5 over 3. So we have 2 different answers for this. Now we have to say find what integer values makes this true. So -1/3 is not an integer, it's just a number. So if we think about our counting numbers on our number line, we have -1/3 here. But that's not a whole number. The next number up would be 0. And then 5/3 is over here. That's our ending amount. So if we actually graph this, we would graph it like 2 open circles, and we would shade what's in between them. 5/3 is not quite 2. It's 1 2/3, but 1 is between it. So here, the only integers that we can choose from are 0 and 1. Those are in our answer set for this. And if this is some review for you for finding the values for compound inequalities and how to graph them, that's great. But if you don't know how to graph them right now, not a big deal. We're just thinking about what whole numbers are between -1/3 and 5/3. And right now it's just 0 and 1. So that's our answer for this one, 0 and 1. We get the same thing there. So it can either be 1 or 0. Let's look at the next one. It says, what are the possible values of x for this next one? So for this next one, we're going to +4 on both sides. And the reason we're doing +4 on both sides is before we get rid of this absolute value, we've got to isolate it. It has to be by itself. So now this is 2 times absolute value of x minus 1 is greater than x plus 4. We're going to divide by 2 on both sides, and we get absolute value x minus 1 is greater than x plus 4 all over 2. If we rewrite that, we get x minus 1 greater than 1/2 x plus 2. So we're dividing both of these by 2. And that's still absolute value now. Now this is a greater than, so we've got to write an or statement. So that means we're going to write x minus 1 is greater than 1/2 x plus 2. That's the first one. We just dropped the absolute value. And the second one, this one gets a little tricky. We're going to write x minus 1. We're going to switch the sign, and we're going to make everything negative. So -1/2 x plus -2. That's just -2. So we made everything negative on the right side. Not just the first term, but both terms are making those negative. Now we're just going to solve these. So we do +1 + 1 for the one on the left. We get x is greater than 1/2 x plus 3. For this one, we're going to plus 1. We get x is less than negative 1/2 x minus 1. We're not done yet. We still have to solve this in terms of what 1x is. So if we minus 1/2 x on both sides, now we're kind of running out of room here. Let me erase some of this, so we don't get confused with where we were at. So now this is 1/2 x is greater than 3. We're going to times by 2 on both sides. We get x is greater than 6. For this next one, we're going to plus 1/2 x plus 1/2 x. That's 1.5 x, or 3/2x is less than negative 1. And now we're just going to times by 2. We get 3x is less than negative 2. Divide by 3. And we get x is less than negative 2/3. So now it says, what are the possible values of x? So we can always graph this on a number line. That can help us. Let's do that. So we don't have a whole lot of room to do this, but let's write negative 2/3 right here. Put 0 somewhere like that. And 6 is, we'll just put it way over here. So let's look at the first piece. It says x is greater than 6. So we put an open circle and we shade everything that's more than 6. X is less than negative 2/3. We put an open circle and shade everything that's less than 2/3. So that's how we can graph that. And so it says, what are all the possible values of x? Those are all the possible values of x. X can be anything that's bigger than 6, or it can be anything that's less than negative 2/3. It can't be anything that's in between there. So we just write the solution like this. We just write or between them, and that's good enough for the answer for this. This very last one is distance from a point. This is not going to be probably going to be on the SAT, even though it's on the subject material. But I really think that you're not going to see a problem like this on the SAT. To summarize, this is an equation that you can solve for to figure out if something is A units away and B is the middle point, and we know point 1 and point 2, we can figure out these different values using this equation. So I'm going to copy this equation so we can kind of look at it at the same time if we need to when we go to this example. So it says, and there, I think there might even be a typo in this example. So it says, given the following equation, points M and N are 6 units away from negative 4. What is the value of M plus B? So for this one, we need to kind of draw this out and see what's going on here first. So if we draw this, it says M and N are 6 units away from negative 4. So that means negative 4 is in the middle somewhere, or it is in the middle. Put negative 4 right there. And we'll put M here and N here. And it says it's 6 units away from negative 4. So that means it's 6 there and 6 there. That's the distance between them. And we want to know, what is M plus B? Well, if we use our equation, it said from earlier, absolute value x minus b equals a. Now I can just kind of plug these things in. So b is negative 4. So we're going to write x minus negative 4, absolute value of that, equals 6 is a. So now we're going to change the sign. We get absolute value x plus 4 equals 6. And we want to know what M plus B is. So first of all, let's solve for what X is, because if we solve for what X is, that's going to tell us what M is, but it's also going to tell us what N is. So if we rewrite this now, we've got this equation. We can write it like this. M plus 4 equals 6. And we can write the other one as N plus 4 equals negative 6. And we can subtract 4 on both sides. We get M is 2. Subtract 4 on both sides here. We get N is negative 10. So now it says, what's M plus B? If we go down further, think that what they were trying to get at is what's m plus n. That's on the next slide there. This might be just a small typo because m plus b, that's 2 plus -4. So if we found out what m plus b is, m we found out was 2 and b is -4. So m plus b equals -2. But m plus n is equal to m plus n is 2 plus -10. And that would be -8. So there is a typo here, and that's why I'm letting you know this, because if you scroll down to the next slide, it's going to say m plus n instead. It says find the sum of m and n, and that's -8. So that's how you use that last rule there. And then finally is just the standard form for an absolute value function. So A tells us the width of a function. HK is the vertex. So if we have something like x minus 2 in here, the x coordinate is going to be 2 for h. So it's always the opposite sign inside the absolute value and the same sign outside for k for the vertex. If this outside number is positive, that's what this means here, a is greater than 0, then our absolute value function opens up. And that looks like this. We have a graph, and our absolute value is going to open up like that. If it's a negative and where the a goes, then it opens down. And then absolute value, or the main function, absolute value of x, looks something like this. We go up 1 over 1, up 1 over 1, up 1 over 1 for our slope, for y is absolute value of x. And that's for this side. And then the other way is up 1, back 1, up 1, back 1, up 1, back 1 for the slope. So that's our parent function of absolute value. And we start at 0, 0. But if this has a number here, we can shift that to the right or to the left. So if it was like y equals absolute value x minus 2, then we would go to the right 2 like that, still be the same slope. We just scoot it over to the right. If we had something where it was like y is, if we had something like y is absolute value x plus 2 plus 4, this one would be, we start the vertex on the opposite side, it goes that way. But because it's plus 4, we're going to actually go up 4 units like that. And for all these, you can just graph them on Desmos, but I just wanted to kind of tell you an overview of how you can graph these and what happens when you graph them. Okay, so here's an example. Again, parent function is the red one. X plus 7, when we plus on the outside, it scoots it up 7 and starts the vertex there. If we do plus on the inside, it scoots it to the left and starts the vertex here. So for this one, we want to graph this. We're just going to scoot it over left 3 units where our vertex is. And we can always make tables on Desmos. In fact, let's do that really quick here. So y is absolute value x plus 3. And so that's the same graph as this here. And we can make a table. You click on the gear icon and click on table, and you can find any value that you need to. All right, so we'll probably go over this concept quite a bit with graphing on Desmos. I think that's something that we'll do very often in this class. There's one that's a little more challenging. -2 on the outside means it's going to open down. This means it's going to shift to the left 1, and it's going to shift down 2 for the vertex. So we can at least start by finding our vertex to begin with. When we find our vertex, it's -1, -2. That's going to be our vertex. And then for the rest of these, you can make a table, and you can find out what these different values are. You can plug in values for x and find out what y equals. That's a really slow way to do this. the fastest way would just be to plug it into Desmos. And you get the calculator on the whole test. So just do that for the test. So we're going to graph this. It ends up opening downward like this way. Same basic idea. It's opening downward. There's an implied -1 here. It's just negative, and that means -1 on the outside. And we can make a table of data. All right, so the first assignment is going to be, double check here. Just had everything open in right here. Here it is. Here it is. So the first assignment is going to be practice set A, number 1 absolute value. And I'll let you get started on that. And then hopefully we have some time to continue and talk about polynomial functions.